All right, so thank you for the introduction. My name is Erin McAweeney. I am a graduate student at the University of Washington Information School, but this work did happen at the University of Michigan over the summer with Haihua, Zhang, and Michael Nebeling. So thank you both for your time and effort for making this happen. So today I'm going to be talking about user-driven design principles for gesture representations. So as many in this room probably know, recent studies have explored user-defined interactions for touch and gesture-based systems through end-user elicitation, originally used by Wobrock et al. While these studies have facilitated the user end of the human-computer dialogue, the subsequent design of gesture representations to communicate gestures to the user vary in style and consistency. So our paper really explores how users interpret, enact, and refine gesture representations. So. First of all, just to clarify what I mean when I say a representation, that is not the gesture itself. Rather, it's an essential part to communicate the gesture in order for the correct enactment to the user. And it can be made up of varying symbols, frames, colors, and perspectives. We find them in our system interfaces, in our tutorials, and our academic papers. And it's really this space between the representation and then the actual gesture enactment itself that this paper is an inquiry into, and that this articulation gap is what we're working to close. All right, so I'll just go through a couple examples of representations that you can see, and while I'm going through them, I want you to think about what exactly it's trying to communicate in the gesture it's asking you to enact. So just go through a few here. And yeah, so as you can see, these are all asking you to do the same thing, a very simple gesture, which is a single finger swipe. And yet we can see various symbols and design components to communicate the exact same interaction. And this becomes especially important to consider when we think of all the papers at CHI this year exploring many emerging interactive technologies and devices, sometimes several at once. And so as we increasingly interact with various interfaces and multimodal systems in our everyday lives, there is an increasing need to communicate these new unfamiliar symbolic inputs and foreign systems or modalities. So imagine the confusion. If you are quickly alternating between different new gesture interfaces with varying design languages, like the ones you saw in the previous slide. So we have these UI patterns in our desktops and mobile phones devices for easier navigation, yet that does not yet exist for communicating gestures. So this leads us to our research question, which is how can gesture representations be designed to help users form the correct mental models to make the leap from symbolic communication to gesture enactment? To explore this, we created two studies. The first is made up of interviews with researchers, some in this room, who have produced gesture representations and an analysis of existing representations in academic papers. This resulted in a taxonomy of graphical elements used for gesture representations, and then our second study used partner elicitation, which resulted in quantitative and qualitative findings around users' mental models when producing and enacting these representations. So, and then finally, we offer design guidelines as a concrete way to apply our findings, and I'll show you two examples of some representation redesigns based on the results that we have. All right, so jumping into study one, due to the exploratory nature of this research, our first study focused on gaining knowledge of existing processes and tools used to create gesture representations. So we interviewed 6 researchers that had led their own elicitation studies. Thank you if any are in the crowd. And we asked about their design processes making these representations. So 3 common threads concerning the production of representations surfaced in the interviews. First was that researchers generally rely on the same tools. These are either Photoshop or Illustrator, both from Adobe. The most common process was tracing over photographs using one of these softwares as a filter, and researchers were generally pretty comfortable with these production techniques. But in terms of the deciding on the design elements that comprise these representations, these were really chosen as an informal ad hoc process amongst co-authors, and were often influenced by the original representation papers. So researchers spoke to maintaining a balance between the ease of production and the communicative effectiveness throughout the production process as well. So the second part of this first study was an analysis of existing representations, which, so we began with classifying the design elements used to encode gestures that we found in existing papers. We applied a grounded theory approach to account for the lack of an existing theoretical framework, and to capture a large breadth of the current papers, we took a sample from the ACM list of citations from the original end-user elicitation paper, end-user defined gestures for surface computing. And in total, this resulted in 30 papers encompassing 3 modalities: touch, air, and object-centric. So you can see here in the taxonomy, first we grouped perspective, frame, and color as structural elements, and these are necessary for the design of any representation and were coded for any representation. Comparatively, we have gesture elements, body context, and environmental context. These are classified as details, which are added to structure to further communicate the aspects of a gesture. And just to give you a few examples in how we went about classifying these representations, here's one example. So in this representation, we have color, multi-frame, first person, ghost, and touch points. Another example, we have upper body, third person, single frame, one-sided arrows, dotted lines, fingers trail, text, and physical object. So this led really nicely into our second study, which contributes quantitative and qualitative dimensions of user-elicited representations refined with partners. By first analyzing and generating a taxonomy, from study 1, we used the results to systematically compare designer and end-user produced representations in this second study. So you can see here, this is our elicitation process. We employed a traditional elicitation method, but also included new adaptations such as priming, production, and partners from Morris et al. And one partner, so you can see one partner was a first-time user of the system that needed to enact the represented gesture, that the partner was the designer that drew that gesture for them. The gesture could only be communicated to the unknowing partner through representations, so imagine this sort of as a game of empirical Pictionary in which someone has to draw a gesture that they see in the video, and then their partner, without knowing the gesture, needs to enact that. So you can see in the process here, they're shown the video, they sketch, their partner then enacts that video. The designer or sketcher, after each enactment, can rates how well their partner did. Then after seeing how their partner interpreted the design elements that they included, they can then iterate on their sketch to sort of nudge their partner to getting closer to the correct enactment of the gesture. They can go through this 3 times if the partner never enacts it correctly. Finally, once they're aware of what the final gesture is, either they enact it correctly or we tell them after 3 tries, and both partners then, after knowing the gesture, can co-design the final representation together. All right, so for the analysis of these representations, we used our taxonomy from study 1 to code a priori. We coded the final 150 co-design representations from the participants using the design elements in categories from our taxonomy. We employed a content analysis method, and the final coding was validated using Cohen's kappa here. So then we calculated agreement amongst the representations. The average agreement across all representations was 0.55. Generally speaking, this indicates good consensus among participants in line with other elicitation studies. You can see here we have 2 that we had 100% consensus for those representations. So our content analysis uncovered 5 aspects that a representation often must articulate using the various graphical elements and design choices. So these you can see here on the x-axis are time, position, posture, motion, and touch. So these are dimensions of a gesture. So elicitations coupled with think-aloud data gave us a better understanding of how the elements from our taxonomy were commonly applied by end users to encode these dimensions of a gesture. So in this graph, you can see we have dimensions on the x-axis, and then the y-axis is going to be the percentage of each dimension and the how much each element was used to encode that dimension. So just to help make that maybe more clear, an example is that you can see, so the breakdown of numbers and frames is about half and half that were used to encode time when representing a gesture. All right. So observations and analysis surfaced common uses and misconceptions when encoding these different dimensions. And I'll show you just two examples. There are many more in the paper that you can check out if you're interested. The first is time. Commonly, time communicated across space was often mistaken as motion with participants. So for example, as you can see here in A, we have an arrow that was used to communicate the order of frames, and this was enacted incorrectly by the partner participant, in which the positions of their hands were incorrect. Secondly, for position, specifically fixed position and stop and ending points relative to the rest of the body were most commonly misinterpreted by the partner participant. To remedy this using body context, such as a symbol of an eye that you see here, this was used by 3 separate individual participants and was used to help clarify the relative position. And it was a new technique that we actually didn't see used in any previous academic papers, but was something, again, that surfaced with 3 different participants. So think-aloud data and recordings gave us more insight into why users better processed and preferred different designs. And so these are just, again, a few mental model observations. There are several more in the paper if you'd like to hear more. This one is quick learner that you can see in A. So because there's no agreed upon language for communicating these gesture interactions, we observed semantic conventions that were established between partners over really a short period of time when creating and interpreting representations. So many participants began learning a sort of graphical language between one another, such as which symbols meant tap or above the surface that you can see here in A. But it is important to note in several instances when the partners contradicted established patterns that they had with one another, sort of these unsaid established patterns, their enactors were unable to identify the gesture or misread the gesture due to a violation of some sort of already established norm. You can imagine if we extend this to the muddled mental models when a user interacts with the system with contradicting design components. And secondly, participants wondered if there was a correct or conventional way to illustrate various gestural elements, seeking a standardized design pattern. Participants sometimes created their own based on cultural knowledge instead to communicate to their partner, such as a metaphor. So commonly understood objects like computer mouse, windshield wipers, books, and stop sign that you can see here in B were used as metaphors to communicate motion and posture of the hand. So what do these different results imply for the future production of gesture representations? Well, our findings indicate disparities in the use of graphical elements between current gesture representations and those that end users had designed for themselves and their partners. Our analysis showed that 56.5% of the final representations from participants were substantially different to those created by designers and researchers. So I'll detail 2 examples of how our findings take user behavior and preferences into account and can be applied to improve existing representations. So the first example is this one on the left, which was included in an elicitation study paper investigating multi-display environments. Our redesign on the right includes several changes in how the representation aspects can be communicated. The side angle helped better communicate the posture of the hand, the touch of the hand on the surface, and the position relative to the surface. Numbers show sequence or time of the frames. Touch points indicate touch in the first frame, and the lack of touch points cues a hovering position above the surface in the third frame. And touch and motion were emphasized with color. So this includes the shadow that shows a lack of touch and hovering above the surface, and the point of view stays consistent throughout the frames. The second example is from Apple's AR human interface guidelines, illustrating the action with a virtual object. Since this is a surface gesture enacted onto a virtual cube through an iPhone screen, the lines are consistently solid to indicate touch. The beginning position also is indicated with a touch point. Starting and ending positions are represented with a ghost effect, and the hands do not occlude the motion lines or the finger paths. So just in summary, this paper contributes a taxonomy for gesture representations, quantitative and qualitative findings on user production and processing of those representations, and design guidelines and principles for designing representations of interactions in both academic papers and gesture-based systems. We've furthered the conversation on human-computer communication and the intentional use of graphical elements to improve the clarity and consistency in symbolic communication of our systems in academic papers. So I'll end there, and I look forward to your questions. Thank you.
Germán from Paris. So we're focusing on sketch-based representations. So my question is, during study 2, when you started with a video clip, do you have cases of misunderstanding from the participants, occlude perspective, any examples?
When they're shown the actual gesture in the video?
Yes.
Or in that they misunderstood the actual, like what the gesture was? We never had instances of that. I think what was interesting was when often people would use the perspective of the video of the gesture that we showed them, but it really was interesting when they intentionally chose to actually change the perspective of the video that they were seeing, really implying that they thought that that would communicate a better gesture.
Cool, thanks.
Yeah. All right, thank you.